Hello, my fabulous pre-calculus class. We are ready for another online adventure. Today, we are going to sketch one cycle of the cotangent function. So it's y equals a times cotan of the quantity bx minus c plus d. And here I took the y equals cotan and I put in the a1, the b1, the c0, the d0. We have a different inequality for the cotangent. So to find two consecutive vertical asymptotes for the cotangent function, we're going to be using this inequality right here. We put the bx minus c between 0 and pi. So this is what you have to remember. New inequality for the cotangent function. But the period formula is the very same. Also, we're going to be using our 5-step procedure. Solve the inequality, find the period, find the increment, find the 5 critical numbers, and then sketch one cycle. And how does this cotangent look? Remember that it is the reciprocal of our tangent function. You see, here you have y equals tan of x when the a is greater than 0. The tan is increasing from left to right. But the cotan will be decreasing from left to right. So they are reciprocals of each other. So we're going to start off with y equals cotan of x. Y equals cotan of x. We only have the x, so we don't have to solve anything else. This is the first critical number, the 5th critical number, vertical asymptote, vertical asymptote. Step 2 will be finding the period. The period is, again, pi divided by the absolute value of b, which is pi. The increment is the period divided by 4, which would be pi over 4. Then we're going to find our 5 critical numbers. We know 0, using our inequality, 0 was the first one. And then we add our increment to get our second critical number. We add our increment again to get our 3rd critical number that I reduced to, pi over 2. And then we have our 4th critical number where we added the increment. Our 5th critical number where we added the increment. You see we ended up with pi. And here we have our 5 critical numbers, using our increment. So we're going to first of all draw our xy axis, and we're going to put our 5 critical numbers here. Remember, the middle critical number is going to always be a point on the axis. It's going to always be a point on the axis. And we're going to be using, since we know the direction, since the a, this is y, is equal to cotan of x. And you know that the a is greater than 0. So since it's a cotan, it is going to be a decreasing function from left to right. So we use our a to come over here and get a second point on the curve. And going to come over here at the 4th critical number and get a 3rd point. So we have 3 points on the graph. And then we're going to do a dot to dot. You see where I drew my vertical asymptotes. Let me see if I can get all that in. Drew my vertical asymptotes. The middle point you see is on the horizontal axis. And then this is a half of a part that's like concave up, and a half that's concave down. And there are no wigglies when we're doing this, okay? No wigglies. So be careful when you are drawing this. So again, it's a half of a concave up and a half of a concave down. If we had y equals the cotan of a negative x, remember we use our properties for where you have the cotan of a negative x is the same thing as negative cotan of a positive x, our even odd functions, remember? So you see it would go in the opposite direction when you have this bx minus c. When this b is negative, you make it positive by applying our properties for the even odd properties. Well, let's do another one. And what we have here, we're going to graph y equals 3 times cotan of 2x. The A is 3, the B is 2, and since you don't see a C or a D, there's 0. Our first step, solve the inequality. Now, how do we undo multiplying by 2? We divide by 2. But dividing by 2 is the same thing as multiplying by its reciprocal, which is a half. When we do that, we get 0 is less than x, which is less than pi over 2. And again, from the inequality, we have 2 consecutive vertical asymptotes, and we also have our first critical number and our fifth critical number. Then we're going to go to our second step, which is finding the period. When we find the period, we have pi divided by the absolute value of b, pi divided by 2. The increment is the period divided by 4. Now, when we're doing the period divided by 4, dividing by 4 is the same thing as multiplying by its reciprocal. So we're getting an increment of pi over 8. Then, again, we're going to find our 5 critical numbers. We start off with the first critical number that we got from our inequality. We add our increment each time. The second critical number will be pi over 2. The third one, 2 pi over 8, which reduces to pi over 4. The fourth one will be 3 pi over 8. And the fifth one will be 4 pi over 8, which reduces to pi over 2. So here we have our 5 critical numbers: 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Then we're going to sketch this. Remember, the middle critical number is always on the axis. And since the A is greater than 0 and it's a cotangent function, we use the A to get a second point on the graph, the A to get a third point on the graph. And then we have a portion that's concave up and a portion that's concave down. And always remember when reviewing these videos to stop, rewind, review. Stop, rewind, review. So always remember to stop, rewind, and review. And my love is going out to you.